And to help you understand how wireless is different from a technical standpoint and how you can translate that into practice from a tool standpoint, we're going to have a great session. But help me welcome Oliver Spatscheck from our labs to talk to you about how wireless is different.
Okay, so I'm going to go all the way down to how actually your application is going to interact with the wireless network. And later on, we will actually have some best practices, and then Doug will really go through it with you in detail. So here I have a little picture which kind of shows what the typical application development usually look like. You have your IP application, and you have this constantly connected line to the internet. And I'm sorry we run out of clouds, but we used the flow here, so I hope that works too. So looking at this on the mobile side, this is actually quite different, because on the mobile side, as has been pointed out before, there's this wireless state machine. And this wireless state machine controls when you can actually send packets to the network and when not. And it goes through the cycles when you want to send packets, and it consumes energy more or less depending on which state it is in. So if you think about it from an application perspective, on the regular internet, you can just write your application and don't worry about when they are sending the data. But on the wireless network, that's not true. I mean, sending it at certain points in time will make a huge difference in your energy consumption, the efficiency, and also the user experience. So going to the next level of detail, I'm showing you here the state machine for a UMTS network. Now, most people are now moving to LTE. The problems in the state machines in LTE are very similar. And as Scott pointed out, actually in LTE, when your radio is active, your energy consumption is even higher. So all the optimizations we're actually going to be talking about today become even more important in an LTE environment than they are in UMTS. But here we're going to stick for a second with the UMTS network. So that state machine has three states, typically. One is idle, one is DCH, which is the high energy state. In the DCH state, you consume the most energy, like a device usually around 800 milliwatt or something on the radio alone. But on the other side, you have a lot of bandwidth. That's when you can really use the bandwidth. AT&T advertises on their devices. Now, if you don't need to transmit data for a while, you will actually fall back into a state which is called fetch. In that state, you have very little bandwidth, you consume roughly half the energy, and in that state, it's really kind of waiting at the end after being in DCH if you still have something to send. And if you stay long enough in this fetch state, then you eventually go back to idle. Now, there are a few other things which are really important to remember here. One is those state transitions take time. So for example, going from idle to DCH takes anywhere between 1.5 and 2 seconds. So from a user experience perspective, you can think about that. If your device is idle, the user will have to wait 1.5 seconds before anything happens, right? On the other side, you have tail times, right? So if you are in this DCH state, the device will not go back to fetch and then from fetch back to idle until there has been no network traffic for a certain period of time. DCH to fetch is around 5 seconds, to give you an example. Now, again, this time is important because during that time period, you're still consuming energy, even though you're not really doing anything for the user or for your application. So in the next couple of slides, I'm actually going to walk you through how an application would interact with the state machine in more detail to kind of highlight how this all works together. So what we put on this screen is kind of a little device which shows you what's going on. On the left side, you will see the state machine we just talked through. And then on the top, if you actually already tried out Arrow, you probably should be familiar with this graph. If not, Doug will show you a lot of those more. But this gives you kind of the graph what Arrow will show you. So you say like, up-down packets, throughput, besides everything. And on the bottom you see this RRC state machine. And the state machine is what basically Arrow adds in there, which tells you what state your device is actually in while those things are going on. So it will tell you if it's going up, down, and if you're consuming a lot of energy or not. So let's start here. The device is idle, and you want to send some data. So the first thing which has to kind of happen is that you're transitioning from the idle state, into the DCH state. We show you this little red triangle there, so that's the 2 seconds delay you have to actually become active. Now you're kind of transmitting data back and forth. You're in half hour statement. You have a lot of bandwidth to your disposal. And so in this phase, everything is fine. That's exactly how you efficiently should be using the network. Now after you're done transmitting, after this timeout of 5 seconds, as mentioned before, you're going to drop back down into the DCH state. Into the fetch state. And in the fetch state, you consume roughly half the energy, but you have very little bandwidth, which means as soon as you're actually using the network again with any sizable amount of data, you will really trigger back an up switch back into DCH state. Now, those up switches are a little bit faster than going from idle to DCH, but they still kind of add delay to the user experience. Again, then you're staying in DCH state, you transmit data, then all the way at the end, what will happen is your device goes idle, which will make a transition back down into the fetch state. And then from the fetch state, if you're long enough idle, the device goes idle again and you're back of where we started with, right? Now, so if you look at this, that should kind of help you understand on a very high level already why it is very important on the wireless side to actually time your transmissions properly, right? If you have medium-sized gaps in between, you're spending a lot of time in those tail times, which consumes energy for no reason, right? If you have larger gaps in between, then you're going to generate a lot of state transitions going from idle back to DCH. Those state transitions not only load our network, which really only developers and users typically don't care that much about, but they more importantly make for a bad user experience because you have to wait until this is going to happen. Right? So the high-level message here is, and it's I guess a fortunate or unfortunate message, the way how you look at it, is that on wireless networks, really everything is connected. You can't just sit on the application level and completely ignore what's happening in the state machine below. And so that impacts the user experience, right? It impacts the device battery life, as well as the network efficiency, right? So I run you really quickly now through the wireless state machine and how it works. And as I said, LTE is very similar. It's actually even more important because the energy in active state is higher. And I will be out there after the session in the lounge. And if you have questions or want any more deeper knowledge on this, please find me.